Many people knows mathematics while only few understands mathematics. In this video, I want to prove to you that 2 plus 2 is equal to 5. Strange, isn't it? Actually, there are a lot of erroneous ways to do this, but amidst all, this method I want to introduce appears to be far better than the rest. This also serves as a way to differentiate between a person who knows mathematics and a person who understands mathematics. This can also be seen as a proof of 4 being equal to 5. In few steps, this will be done. Step 1. Start by writing 2 plus 2 equals 4. Follow each steps carefully. Look out for any mistake. You may be smart enough to discover where the workings go wrong. 2 plus 2 equals 4. It is also right to add and subtract equal value to an expression. When we add and subtract x from the expression on the right-hand side, the expression remains the same because the x's cancels out. Since x can be any number, let x be 9 over 2. The expression on the right-hand side is thus 4 plus 9 over 2 minus 9 over 2. The positive 9 over 2 is coming before the negative 9 over 2. I can interchange it and it will still be correct. So it becomes minus 9 over 2 plus 9 over 2. Step number 2. Group the first two numbers on the left-hand side. This means that 4 minus 9 over 2 will be formed within a bracket while plus 9 over 2 will be separate. So, 2 plus 2 equals 4 minus 9 over 2 in a bracket, plus 9 over 2. Let's pay more attention to the bracket. What if I introduce the square root and balance it with a square? So I write 4 minus 9 over 2 under root square, since the square root cancels the square as an inverse operation, and this comes into the expression. Another observation is that 4 minus 9 over 2 can be treated with expansion. Then, the expression regenerates to 2 plus 2 equals the square root of 4 minus 9 over 2 square, plus 9 over 2. I will rewrite this on a new page for clarity's sake. We can now expand 4 minus 9 over 2 square by binomial expansion, knowing that a minus b square is equal to a square minus 2ab plus b square. Same idea gives 4 square minus 2 times 4 times 9 over 2 plus 9 over 2 square, with the square root being intact. Let's simplify the expression under the root sign a bit. Then we have 16 minus 36 plus 81 over 4. Now we have 2 plus 2 equals root 16 minus 36 plus 81 over 4 plus 9 over 2. Since 16 minus 36 plus 81 over 4 is equal to 1 over 4, 2 plus 2 equals root 1 over 4 plus 9 over 2. The square root of 1 over 4 is 1 over 2, so 2 plus 2 equals 1 over 2 plus 9 over 2, which is equal to 10 over 2, then 5. Finally, 2 plus 2 equals 5. Question: where is the mistake? Where is the error? Can you find any? You are free to reconsider the steps before I explain the vicissitude. To see why the result happened to be 5, let us retrace our steps back to where the square root sign came in. How true is it that 4 minus 9 over 2 is same as root 4 minus 9 over 2 square? When a number is positive, its square root must be a positive number. For a non-negative number x, the square root of x is always positive. The interval notation suffices, which means that the result for the square root of x can take values ranging from 0 then continues to the positive infinity. Another way to write this is root x is greater or equal to 0 and less than infinity for all non-negative real values of x. Example: the square root of 4 is equal to plus 2. The square root of 100 is equal to plus 10. The square root of 196 is equal to plus 14. These affirm that the square root of a positive real number is always positive. What happens when x is a negative? The square root of a negative number x remains positive for all non-negative real values of x. This is a variant of the discussed positive part, but in this case, we will be dealing with imaginary numbers. Example: the square root of -1 is positive I, where I is the complex number. Similarly, the square root of -4 is positive 2i. Another, the square root of -16,900 is positive 130i. What can we infer from all these? Answer: the square root of a number is always positive, whether the number is positive or negative. Let us even see what 4 minus 9 over 2 will give when treated separately. 4 minus 9 over 2 is equal to minus 1 over 2, but the square root operation we added gave a positive result of 1 over 2. This is where the error came in. The negative number, minus 1 over 2, can't be treated with a square root sign and a square, with the aim of canceling each other. There is no such number whose square root will yield a negative number. That is another point to behold, although it has been explained in one of the previous lectures. If you wish to introduce the square and the square root psi, the square root should be inside the bracket, while the square serves as the overall. This is the only way to conserve the negative and positive nature of every number. So, any number x is equal to the square root of x, then we square it. Minus 1 over 2 can be treated as square root of 1 over 2, then we square it. If the square is coming before the square root sign, it implies another definition to what we intend to write. The square root comes as the overall symbol. It means we have the absolute value function. The square root of x squared is the absolute value of x. The absolute value functions to give a positive result for all numbers taken as x. Now I hope you understand that 4 minus 9 over 2 ought to be translated in terms of the second expression here, and not the first. Thanks for watching.